Hello guys, welcome to another exciting episode of Cybersensei walkthroughs. Today we're having a video walkthrough on reverse engineering and from the picoCTF 2026 challenges. We're having silent stream. It was medium rated, and the description goes by we recovered a suspicious packet capture file that seems to contain a transferred file. The sender was kind enough to also share the script they used to encode and send it. Can you reconstruct the original file? Download the pickup file here and the sender's encoding script here. So you can go through the hints. So the encoding script is a clue. Focus on what it's doing to each byte before it's sent. The second hint, the flag is hidden inside the file. Try reconstructing and opening it. The third hint, don't rely on everything you see, including flag format. Okay, amazing. So I've already downloaded the two files, the pickup file and the encoding. They're already here. Encrypt this is the encoding and the pickup file. I'll open my terminal here. Let it load for a minute. I'm going to maximize. Let's cut encrypt, so you can see all that. So I'm going to open the pickup file so that you can see the transferred files. It's amazing, it's a good one. So you can see the source. The source is the same, it's constant. The IP address 10.10.10.10, amazing. And the destination IP address is also just one, IP address 10.10.10.11. That's a good note, that's amazing. So we can also check things like the TCP stream. So notice I'm having it as a row. Someone can change everything here, but you'll come to understand why you need that. Go back to our encryption file. I'm going to open it with the VS Code. So we have to analyze this so that you understand whatever is happening here. So check this out. So this function encode byte, this is the function encode byte. So it takes the input B and a key. So what does it do to the two variables? So it returns the input, the B, and does addition to it using the key. And a key, it's provided here. This is the key. It's now in this instance it's going to be used as 42, but remember this is another function. It may be used, another key can be used like 50, 90, any of them. So right now there's one thing you need to notice also here. This is called the modulus then to 56. So what does this do? In this instance of encryption, it handles overflowing. I'll give you an example. So we need to have a certain range of what you are dealing with. So let's say you have input B, the original value is maybe 220, right? Not 220, let's do 230, right? 230. I'm going to maximize this so that you can see it well. 230. Then remember the key is 42, right? So the key is 42. So when you add 42, so in this instance you'll get an answer of 272, if I'm not wrong, 272 bytes. So notice we can't have an overflow because this is already an overflow with the limit 256. So does it do the modulus function? It does modulus 256. So we have an overflow of how many? Let me do the math. Minus 256. It has an overflow of 16 bytes. So we get our final answer as 16 bytes. So this one handles the overflow so that we have a specific range of whatever we're dealing with, of every byte we're dealing with. And this is what we call, I'll refer to it as the Caesar cipher of the type of encoding that it does. So this other function, it's doing a simulation of a flag transfer. So you're given a file name and the key. So printf flag transfer, file name, encoding byte, encoding key, the key. So the key that has been entered is 42. We go back to whatever we're dealing with. So one thing you should notice here, there's this file that was transferred. So how do you check the file? You need to check the file, and to check this file, you'll do this simple process. You see the same process I did to see this follow TCP stream. I'm going to repeat it again. You're going to right click on any packet, random packet. You're going to follow that, the drop down of follow, then TCP stream. And a TCP stream, mostly you'll get, according to how you've been using your Wireshark, because remember this is Wireshark, this is a tool, it's called Wireshark. It can be having xdump, actually it might be having UTF-8, but I need you to use raw. So raw will captures the raw data that you need, and I'm going to save it as a bin file. So we are in silent stream, so I'm going to save it as data.bin. Let's use data.bin. So once it's saved, you can notice it's here. Now I'm going to introduce another script that will actually handle the reading and decoding of the data that's here. Remember, you can't actually just read the data that's there. Let's cut file data.bin. It's data, yes. So cut. You can't actually. It's not in plain text. That's what I mean. Data.bin. You can actually see it's not in plain text. So we need a code. We need a Python script. I've already created a Python script that will decode this and actually feed it into a picture where we can get our flag. Because remember, there's already the process of encryption that was done. Now we need to do the decryption part, because the file being transferred is already encrypted. Now we need to get our original data that was being transferred, which will be our flag. So I've already done the script. You'll get it. I'll put the link in the description. This script solve.py. I'm going to download it. Let me just copy it. I think it will work. Sudo nano solve.py. Main reason I'm doing this is so that I can edit what I want. So remember, it's going to read a file. Remember how we saved our file? You must know how we saved our file. Our file was saved as data.bin. So it's going to actually open a file data.bin. And remember, if you actually saved your file, so maybe something like the let's call it, the challenge is called silent. So let's say you had called your data, your file silent.bin. You have to change this part to be silent.bin. I'm actually going to do changes of that code so that one actually identifies where they need to enter their specific name of the data they called it, or how they called their file actually. But if you just call it data.bin, no need of changing it at the moment. So notice the encryption, you must understand how the encryption was done so that you can do the decryption. The encryption was being done by adding a key of 42, right? So now here you must do the subtraction, because remember we were dealing with a key of 42. So we're doing the subtraction of 42, and now we still need to deal with the modulus. I'll take you back to the mouse pad. So let's say you have the encrypted byte. Let's give an example of 28, or let's just say 20, and you are subtracting 42. So this will actually automatically give you a negative value of negative 22 if I'm not wrong. This is actually not okay. This, you can't have a negative byte. So what do? You deal with the modulus. So in the decryption code, modulus is dealing with underflow, while in the encryption it was dealing with overflow. So it's going to deal with the underflow. So for B in the encoded data, exactly. So remember, this whatever was in our bin file, it's now called encoded data. So it's going to decode it, and it's going to feed it into decrypted data.gpg. It's a flag. So we can actually even change this. You can even call it our flag. We have you're the one in control of the code, so you can name it as you want. It's going to now give us a file, our flag.gpg. You can even, I'm going to change this. Sorry for that. Recovered our flag. Let's just do some changes there. Flag.gpg. Once you do that, you can close this terminal. You can close this nano text editor, and you're going to run that code. Solver.py. So you can see the file recovered as our flag.gpg. If you ls, you're going to see that file, our flag.gpg. You can actually just check it now. Notice what you have now. We have the flag down. You have the flag inside it. picoCTF, track the traffic. Now that string. Once you enter that in your platform, you already get the flag. So a quick recap: you were given an encryption script. The encryption script is where you identify what was being done. It was being added a key of 42, and they were dealing with modulus the 256. So the same process you use, now you reverse it to decrypt it. And what are you decrypting? You're decrypting the file that was captured, the traffic. So whatever packet you choose, just right click it, follow TCP stream, then get the data as raw data. So you're going to save it as .bin file. You're going to save it as .bin file. Then the exact .bin file you're going to feed into your solver.py. I'm going to put a description, the link to my GitHub repository, or GitHub repository, in the description, so that you can get the code directly from there. Just change the few details you need, and you're going to get our flag. Thank you so much for watching, and see you in the next one. Bye.